Hello agents, today I will talk about C streams. What is a stream? The term stream is an abstraction of a construct that allows you to send or receive an unknown number of bytes. The metaphor, as you can see in the picture, is a stream of water. You take the data as it comes or send it as needed. On the contrary, for example, an array has a fixed known length. So in a stream, you get data and you don't know the length, you just keep reading or writing. So what can we do with stream, you may ask? Well, where streams are used include reading and writing to files, receiving or sending data across external connections. However, it's important to remember that the term stream is generic and says nothing about the implementation. So here we have a function we mainly use with a stream, which is printf. The printf function, however, is not part of the C library because there is no input or output defining the language itself. The print function is just a useful function from the standard input-output library. And here we can see how to use it properly. We can use format, which has been explained in previous seminars, so I won't go deep into it. But as you can see, we use different letters to specify the different formats we wish to print. So as you may remember, this for decimal, I for integer, and so on. But there's also a catch. We can also use flags, width, and precision. I won't go into very detail, but you can see it later in the presentation, but I'll just explain that minus is for justifying, 0 fills the gaps with zeros, then the width number, it says the main width of what you're going to print, and then precision, it's the same as width, but just after the dot. So let's see with an example. Here we can see we can print an S, which is a string. We print a decimal, 1, 2, 3, 4, 5, and here it gets interesting. 04 prints 0025. 4 is the width, and 0 fills the gaps that are needed for the width. We can print an integer. Here we have a 3.2f, which would print 3 of width before the dot and 2 of width after the dot. So as you can see, just the 14 is printed. Then we have hexadecimal, octal, unsigned value, and if we wish to print the percentage sign, we use double percentage. Here we also have some indentation for printing. The percentage S just prints the same. The 15 of width, it makes it be, it forces it to be of 15 width. We also have the precision, the justifying, and as you can see in the two ones below, the precision forces it to be 15 of width and after the dot 10th, but since there is no dot, it just gets cut. But if we justify it, it gets to the left side, but it's still getting cut since there is no width, since there is no point. The scanf function isn't in the C language, but it's in the standard input-output library. Here are also formats and modifiers. We can use width, the modifier, and finally the type. So here's how to format. With an asterisk, which is optional, indicates that the data is data to be read from the stream but ignored. Okay, so we can also use the width, which is the maximum number of characters, modifiers, and the type. So as we can see, for example, here I have a scanf and I'm only going to read 3 of a string. Then I'm going to print it. After that I'm going to scan a character and then I'm going to print it. And here we can see the example. And I'm also scanning for an integer and printing it. And here we see at first we give the string, which is HOLL, and then we give the character, and what I print is just the 3 first characters, then I just print the next character, and finally I print the number. And the qualifying inputs are the same as the printf, so there's no need to worry about that. Now let's go to file stream. A file stream is a stream that is linked to a file using an open operation A stream is disassociated from a file using the close operation, as you will see later. The current location, also referred to as the current position, is the location in a file when the next access will occur. There are two types of streams: text, which are used with ASCII characters or some character translation takes place, and binary streams, which are used with any type of data and there is no character translation. To open a file and disassociate it, we use the fopen. So here we can see the fopen has some modes. So a FNF, it's like all file system function. It uses the header stdio.h as mentioned before. The name of the file to open is pointed to by fname, and the string pointed at for mode determines how the file may be accessed. So here we can see we have different modes. R is for reading, W is for writing, and A is for appending. There are just modifier after that, which is B for binary, plus for text, and both if needed. And here's how we can manipulate. As mentioned before, as we can open, we can also close a file. So here's just the country function, which is the fclose function. It uses the file type. As you may notice, this file type isn't in the C language, but is in the standard input-output library. And we can also read and write. We can, as the functions mentioned before, just open the stream or close the stream. But to be able to read from the stream, we need to use these functions. So the getC function reads the next byte from the file and returns it as an integer, and if an error occurs, returns an end file. The getC function, however, also returns an F file when the end of the file is reached. Your routine can assign fget return value to HR. You don't have to assign it to an integer. The fput function writes the bytes containing to ch to the file associated with the file pointer as an unsigned char. Although ch is defined as an int, you may call it using simply hr. The fput function returns the character written if successful or end of file if an error occurs. So here, noticing again the function, we can see it's an int ch. And let's get into the matrix or binary streams. A binary stream consists of one or more bytes of arbitrary information. You can write the value stored in an arbitrary object to a byte-oriented binary stream and read it exactly what was stored in the object when you wrote it. A binary stream treats a file as a sequence of bytes, which is what most files are. Within the program, the stream looks like the same sequence of bytes. But let's recall the difference. Binary files have no inherent constraints. They can be any sequence of bytes and must be opened in an appropriate program that knows the specific file format. Text files must represent reasonable text and can be edited in any text editor program. So as you may see, an example for binary files are media player or Photoshop files. If you try to open that on a text editor, you would see just a lot of characters you wouldn't be able to recognize. Then remember that all files, whether binary or text, are composed of bytes. The difference between binary and text file is in how these bytes are interpreted. Every text file is indeed a binary file, but this interpretation gives us no useful operations to work with. The reverse is not true, and treating a binary file as a text file can lead to data corruption. And our good old friend, the stream buffer. A buffer is a region of a physical memory storage used to temporarily store data while it's being moved from one place to another. So in this case, a stream. Typically, the data is stored in a buffer as it is retrieved from an input device, such as a stream, or just before it is sent to an output device, or maybe an output stream or a program. However, a buffer may be used when moving data between processes within a computer. And to To conclude, here are other types of streams. It's the file type, standard input, the standard output, which are the ones we normally use for our programs in the terminal, and there's also standard error stream, which is used for error messages and diagnostics issued by the program. So I hope you found this presentation useful. Please be sure to like it or ask questions if needed. And thanks for your attention.